Hi guys, I hope that section P4 went well for you. Today we're going to start taking notes on section P5. You'll do that today. Next class you'll take notes on more of P5 with some more practice. And then the last class that I am not there with you for, you will do some just extra practice on factoring. Okay, so let's get started with our P5. We just finished the section on multiplying polynomials. Now we will unmultiply polynomials, called factoring. And then I had a question here that I said, how important is factoring? And I'm just going to move the camera over here for a minute so you can see my face. Factoring is probably one of the most important things we're going to do in this class. Okay? You need to, seriously, you need to get very, very good at factoring. You need to be able to do it efficiently, which means that you can do it without too much time, and also that you can do it correctly every time. And the way that you're going to get better at factoring is to practice, practice, practice. Okay? So over the next 3 class periods, you're going to be doing a lot of factoring, and you need to do it. This is so one of those topics where you don't want to just, hey, I forgot to get my homework done. Can I just see yours and let me, copy off your problems? Because, yeah, it'll be fine. If you do not practice factoring, this class will be very hard for you the rest of the year because we will be factoring a lot, okay? So I don't know how much I can stress to you how important it is. Okay, so please, 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 please work very, very hard on this section. Make sure you have practiced. Make sure you know what you're doing. Some of these things are going to be very common to you. You've seen them before. You've done them before. Some of them are not. Okay. In addition, you will find that I do things sometimes differently than other teachers as far as the factoring goes. When we get to those points, I will mention them, but I'm going to tell you right now that I have my favorite method for factoring. Other teachers have their favorite methods. We can talk about the differences later on when I come back, but if the method that you learned last year works for you, you like it, you remember it, that's the key, remembering it, and you remember it and you like it, great, and you can do it well, go for it. Please do that method. It will not bother me one bit whatsoever. However, if you can't remember how that method goes or whatever, you decide you like mine better, that's fine too, okay? All right, with that being said, let's get started. All right, back here on our notes. So we're going to be talking about several methods. I think, in fact, in this lesson, 7 methods, which is quite a few, so it's going to be a few videos, so hold on. The first one we're going to talk about is GCF. Hopefully we're all aware that GCF stands for greatest common factor, which is also considered to be reverse distributive, okay? And I also wrote on here, recall that when we distribute, we multiply, right? When we're distributing things, we do so with multiplication. When we factor or think about doing undistribute, obviously we'd have to do the inverse of multiply, which is to divide, okay? And the only other thing I'll say maybe about this one is always do this first, if possible. Sometimes we won't have a greatest common factor, sometimes we will, okay? So let's take a look at an example, or a couple of examples. We've got, let's see, make sure that I can tilt this down so you can see it. 10x cubed minus 4x squared. Oh, here, let's say factor. Number 1. 10x cubed minus 4x squared. So we're looking for a greatest common factor. We want to look at the coefficients, in this case 10 and 4, and determine if they have anything in common. They do. They have 2, a factor of 2 in common. And then we'll look at the variables x cubed, x squared, and find out how many factors of x do they have in common. They have 2 factors of x in common, so we call that x squared. Now we're thinking about dividing, right, when we undistribute. So it's like we're doing 10x cubed divided by 2x squared. Well, 10 divided by 2 is 5. X cubed divided by x squared is x. Or sometimes I might think of it as we had 3 factors of x. We took out 2 factors of x. How many factors of x do we have left over? 1. Okay, then we have minus. That sign won't change. 4 divided by 2, which is 2. We had 2 factors of x. We took out 2 factors of x, meaning that we're left with no factors of x. And this would be our final answer. This is factored form. Okay. All right, next example will be, oh, interesting. It's a good one. See if you guys can see that one. You can. 2x times x minus 7 plus 3 times x minus 7. Now, we're doing a little greatest common factor factoring here. Here's what I need for you to understand. Grab another marker. This is a term. And this is another term. Okay? And the factors of this term are 2, x, and x minus 7. Okay? 3 factors, things that were multiplied together. 2 times x minus 7. The factors of this term are 3 and x minus 7. Again, what was multiplied together to get this term that's then they're separated by addition. Okay. So then if we're looking for the greatest common factor, I want to know what do these 2 terms have in common. They have a factor of x minus 7 in common. Okay. Now I might actually use a bracket here. And you'll see why in just a minute. I think it's just a matter of notation, and then we can switch it back, but sometimes it's helpful. So I have this term. I have a factor of 2, a factor of x minus 7. I took the x minus 7 out. What do I have left over in this term? 2x. Plus sign. Now I'm looking at this term. I had a 3 and I had an x minus 7. I took an x minus 7 out, leaving me only with the factor of 3. Now, I don't really need brackets around that. Sometimes the brackets are helpful when we're working the problem so that we can kind of see that this is what they had in common. Bracket, here's what's left over. But basically, we're going to be able to rewrite that now with some parentheses so that this is our final answer. Okay, so we just factored this with greatest common factor. Okay. Next method. Let's see what my time is. I think we can get to the next one. The next one is actually going to feel kind of similar to what we just did, called grouping. Grouping is, oh, you can't see that. There we go. Grouping is useful for polynomials that have 4 terms. So that even when there is no greatest common factor, sometimes we can strategically group terms together so that we can find a GCF. Okay, so I'll show you an example of this one. Let's see, x cubed plus 5x squared minus 2x minus 10. Okay, so if I look at all 4 terms here, they do not all have a common factor. So we might think, oh, well, there's nothing we can do. But instead what we're going to do is we're going to group them together. And I'm going to group them this way, those 2 together, and I'm going to group these 2 together. Okay. And we're going to look at now these 2 terms, x cubed and 5x squared, and try to find out what do these 2 terms have in common. They have x squared in common. And so then we'll try to figure out what's left over. Again, I had 3 factors of x. We took out 2 factors of x. It leaves me with 1 factor of x. Here I had a factor of 5, and I had 2 factors of x, but I took those out, so I'm left with just x plus 5. Okay. Now we're going to take a look at negative 2x and negative 10, and we're going to try to figure out what they have in common. And what they actually have in common is a negative 2. Now, be careful here because at this point we're going to be able to, we need to divide. So negative 2x divided by negative 2 is positive x. Negative 10 divided by negative 2 is positive 5. And hopefully after we just did the GCF factoring, you kind of see what's going to happen here, right? Now we're looking at this term, and we're looking at this term, and we're trying to figure out what do these 2 terms have in common. Hopefully that's not too hard to see. They both have an x plus 5. And then I might, again, try to use brackets to help me out, just visually. What's left over is, oh, it's going to fall. X squared out of this one, negative 2 out of this one. And again, we don't need the brackets, so I might switch that up and just put that in parentheses instead to get this for my final answer. Okay. All right, I'm about out of time on this one, so we're going to do the next one, which you can see right there in the next video. See you in a minute.